So our first problem here, this is target number 5. The polynomial p of z equals 8z cubed plus 8z minus 5 has exactly one rational root and two non-real roots. Compute the sum of the squares of the two non-real roots of p of z. Express your answer as a common fraction. All right, so here we're given the clue that there's one rational root and then two non-real roots. Presumably from a quadratic, if you have the quadratic formula, there should be, if it's non-real, it's going to be complex. There's going to be an imaginary part in there. We've got to find this one rational root. And we can do this via the rational root theorem. There's really no good way to kind of find the root that you want, given without like actually knowing that what the form of the root is, besides given that it's a rational root, so it makes the search a lot easier. We can search from the constant here, p, which has factors of plus or minus 1 and plus or minus 5, and then q, plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. Notice that q is here and p is here. To do this search, you can do this search, or since you have a calculator, you can easily graph this on your TI-84s or whatever legal graphing calculator you have that you can use for this round of the test. And you should get z equals 1/2 as the rational root for this polynomial. So we can actually do some synthetic division to kind of get our quadratic. 4 to 10, 5 should give you 0. So we have z minus 1/2 times 8z squared plus 4z plus 10. And we can rewrite this in a more factored way. We get 2z minus 1 times 4z squared plus 2z plus 5. So we know that this gives us z equals 1/2. Now we need to find the roots of 4z squared plus 2z plus 5 equals 0. There's actually two ways you can do this. You can either use the quadratic formula, and that's pretty straightforward. All the imaginary parts will cancel, and you'll get the sum of the roots. You'll get each root, and then you can just square them, and you'll get your formula. Or we can do the math traditional way. This is using Vienna's formulas with an actual leading coefficient that's not 1. So we have ax squared plus bx plus c equals 0. And let's say this factors into something like has roots of like p and q. Then p plus q is going to be negative b over a, and pq is c over a. Right? So to find p squared plus q squared, recall the identity p plus q quantity squared is p squared plus 2pq plus q squared. So we have the sum of two squares of the roots and the 2 times the product of the two roots. So you can just rewrite this as p plus q quantity squared minus 2pq. This gives us p plus q will be negative 2 over 4 is negative 1/2, and pq will be 5 over 4. So we'll get negative 1/2 squared minus 2 times 5/4. You get 1/4 minus 10/4, and our answer is negative 9/4.
Hi, everybody. This is Tim. Hope you're enjoying our videos. If so, you know what to do. Like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.